Welcome to this edition of Math Dive in About 5. Today we'll be focusing on volume. My name is Barbara Knox.
And my name is Daryl Frost. Welcome.
When you get to the next slide, you're going to want to pause the video. There are 3 tasks on the next slide. For each one of those tasks, I want you to think about what the prerequisite skills are that the students are going to need in order to be successful with that task. Also consider the misconceptions that students are going to have as they're learning about volume. All right, so we see volume mentioned in both 3rd and 5th grade benchmarks. Daryl, how are the volumes different in 3rd and 5th grade?
I'm glad you asked because there is a difference, and I think there sometimes gets some confusion. The volume in 3rd grade is talking about liquid volume.
Usually measured in something like a graduated cylinder, looking
cup,
at a number line representation.
Yes. And then the volume in 5th grade is focusing on the volume of a shape, and in this case it's a right rectangular prism, which means it's got all right angles.
Correct. All right, so when we're talking about the base of a right rectangular prism, because some of the formulas do use base times height.
Sure.
We're talking about a 2-dimensional figure.
It has length and width.
Right.
Yes.
So here would be the base of a rectangular prism.
A grid or an array.
We don't want to build that with cubes yet, because as soon as we build with cubes, we've got the additional dimension of height.
But I've seen that before where the bottom layer is built, and that's called the base, so that's actually inaccurate.
Correct, because the base is that 2-dimensional part of the figure.
So like centimeter paper,
yes,
you could use
centimeter grid paper.
Centimeter grid paper. You could create the base
and then have them build
on top of that.
But
that
to get the distinction of the 2 dimensions versus the 3 dimensions.
Yes.
Because as soon as we build it with cubes,
you have a layer.
Have a 3rd dimension of
with
height.
Yes.
So as we stack layers, we have the area of the base times the height. To get the area of the base, we're going to multiply length times width. So if I had that centimeter graph paper on the bottom, the length times width would be
4 groups of 7, or 4 times 7,
which would be
in 5th grade,
a total of 28 square units.
Yes.
So as I'm doing the multiplication, I can multiply length times width times height, which is the length times width is 4 times 7, and I have 1 layer, so it's the height of 1 centimeter. But I can also think about it as being the base of 28 times 1 layer, which is
28
cubic centimeters.
Yes. And that really, and if you go through there and keep adding layers.
Which we're going to. So here I'm going to add another layer.
Yeah.
Now how many layers do I have?
You have two layers, or 2 centimeters tall, or height.
So the only thing that's going to change in my formulas is going to be the height, right? I'm changing the height now to 2 layers.
But a good question to ask is, can you develop a quick way to calculate this?
Yes.
That's versus telling them.
Because we want them to come up with the formula, right?
So
we don't want to tell them the formula.
That would be a question to ask. It's like, can you come up with a, if they understand this, is there a shortcut that you could use once you've developed this understanding through a task like this?
And the only thing that's changing as I add more layers is going to be the height. Everything else in my
and you would want a student at 5th grade to say, well, if I just find the area of the base and multiply it by the height, that's going to give me the volume every time of any right rectangular prism.
I keep building here.
But again, point being, you're not telling.
You're not telling, you're wanting them to discover.
You're building discover that through a task such as this.
Yes.
Yep.
And 1 more layer.
There we go.
So now we have 7 layers tall. So looking at your first task, you were asked to find out how many cubes were used to make that rectangular prism. What's one way a student might do this, Daryl?
Well, I mean, there's lots of strategies. For some students that are struggling, they need to count every single one of those cubes.
So they might need to get out the cubes
and count them.
Mm-hmm. If you have centimeter grid paper, cut out some nets from some centimeter grid paper and fold it up and let them build inside those nets so that they can see.
And then from counting, you want to go to, okay, is there another quicker way you could count? And that starts looking at layers and then developing.
So finding that area of the base, which would be the 6 centimeters by 6 centimeters. I have 36 square centimeters.
Yep.
The prism's 3 layers tall, so I have 3 groups of 6 times 6.
Right.
And again, we can do the length times the width times the height to find.
And it also brings in properties. That's a prerequisite skill. You could see the associative properties there.
In task 2, you were asked to take 36 cubes and create as many rectangular prisms as you could that had a volume of 36 cubic centimeters.
I think this is a great task, so they could come up with all different kinds of ways.
And having them record the dimensions. What was the length? What was the width? What was the height? So here's one possibility.
Sure.
We're going to show you a couple of possibilities. This is not all of them. There are other possibilities. Think about even if you rotate that.
I could do a 12 by 3 by 1.
Yes, you could.
Yeah.
All right. And this is a task that you'd be leading the students toward. We worked with cubes.
Right.
Now we're working with prisms and just being given the dimensions, having to find prisms that have the same volume.
Students need practice with all those cubes, representations, and then to look at something like this, very abstract. So I would not begin my unit on volume with this.
Correct.
They're not there.
Correct. The third task was probably a little bit more challenging, and if we think about the prerequisite skills that students need for this task, they not only need to know about area and what volume is, but
they need to understand division.
Yes.
And really being able to manipulate that formula in a way that, okay, I know the volume and 2 side leaks, how do I find the other side?
So first they're going to have to find the I can take the 9 times 5 to find one dimension, or the 2 dimensions,
2 dimensions,
right?
Yeah.
And figure out that that's 45. Now I know that I'm multiplying 45 times something else to get that 540.
And if I understand inverse operations and I can
the relationships between multiplication and division, then I know that I'm going to have to divide to find the missing
side length,
yes.
12 centimeters. And I did remember to say centimeters.
And looking at that CRA model, we want to build rectangular prisms using cubes. That's where we want to start with our students.
Yes.
And then the representational piece would be a visual image of a rectangular prism. So this would be printed on a piece of paper, where they don't actually have the prism to be able to count the cubes.
Could they also draw them themselves, a 3D shape?
They could. It's a little bit challenging for them to draw a prism. But
that could be a way to differentiate.
It could. And then your abstract thinking, where we have to use the volume formulas to find that volume. Thank you for joining us today for this edition of Math Dive in About 5. We'll see you back next time.
Bye.
Bye.